Hello friends, today now that we have completed our discussion on DSS, we are going to talk about another component of management information system, another subsystem within the management information system, and that subsystem is known as the expert system, right? As the name suggests, it provides you expert knowledge on a particular domain, in a particular domain. So this is how the expert systems help in the management of a particular domain in an enterprise, right? So let us have a look at what expert systems are. As I said, they basically offer solutions to problems in a particular domain by emulating judgments of the human experts. So they offer solutions to problems in a particular domain. So they are only going to offer solution in a particular domain. We said in DSS that the scope of DSS is narrow. Expert system is even narrower. The scope is even narrower, right? So this is one characteristic of expert system. They provide solutions. They actually don't provide solutions. They offer various possible alternatives that can be exercised to resolve problems. And these problems are in a particular domain, which means that these problems basically are from a particular area, and the expert systems are area specific, domain specific. So one expert system would not be able to provide solutions to HR problems and marketing problems, all kind of problems. No, we said that the focus is going to be narrower, and expert system would have expertise in a very narrow domain. For example, expert system can have an expertise in evaluating and comparing the profitability of various capital budgeting decisions. So I hope you have read about capital budgeting in financial management. So supposing you want to make investments and now you want to find out which particular project to make investment in. So now that job of predicting the profitability of the different projects that you have, this is performed by the expert systems, right? So this particular expert system would only have expertise in doing this particular job. If you want to use this expert system to predict the sales of the product in the market, this expert system would not be able to provide you that functionality. So expert systems are basically having a very narrow domain, and that happens with an expert. If you are an expert, you cannot be an expert of everything. You will have to have an expertise in a very narrow domain, and that happens with expert systems also, right? And how are they able to provide these kind of expert solutions? They basically do what? They emulate the judgments of the human experts. They imitate the judgments of the human experts. So they basically copy the way in which the human experts make judgments, and they also benefit from the expertise of the human experts, and they utilize all that expertise to provide solution. Now, how do they benefit from the expertise of human experts? That we are going to discuss in a short while from now. See, is accumulation of all expert knowledge in a domain. So basically what happens is, all the expert knowledge in a particular domain, in that particular area for which you have designed the expert system, that is collected and that is fed into the expert system, right? So all the knowledge, whatever the expert knowledge exists in a particular area, that is collected and fed into the expert system, right? So this is how the expert systems are, we said that the expert systems emulate judgments of human experts. They emulate their judgments because they have all the information which the human experts have. So that knowledge is fed into the expert system, and this helps them make decisions like experts. However, the solution would depend on user response to questions asked by the system. Now, how does this particular system work? It poses queries to the users, and the users have to respond to those queries. So, depending on what the response of the user is, they provide solutions. Fine. For example, I'm just giving an example. For example, they might pose one query to the user, and I'm taking the same example which I had taken a little while ago. They might pose this query: okay, what are the expected inflation levels in the next 5 years? Depending on your response regarding the inflation levels, depending on the user response regarding the inflation level, now the expert system would give projections for estimations for forecast for the profitability of different projects, right? And then the user can look at these forecasts and decide which particular project to invest in. So the system here asked, what did the system ask from the user? It asked as to what are the projections for the inflationary scenario in the next 5 years, because that helped to determine the profitability level of the project, right? So these kind of questions, these kind of queries it would pose to the user, right? Now let's have a look at the diagram of the a schematic diagram of the expert system. Now please have an understanding of this particular diagram. You would find that this is the user. He need not be an expert, and he wants to know as to which particular project to invest in, and he's got a number of projects in front of him, and he wants to find out which particular project to invest in. There is a user interface. I hope you understand the interface through which the user is communicating with the expert system. So this is the user interface, and we have discussed what user interfaces are in DSS also, right? Now please understand, how is this expert system built? Now, this is the brain of the expert system, please. Now how is this built? See, there is a knowledge engineer who would do what? He would basically collect information from all the human experts in the particular area, right? So in this case, he would probably collect information from all people who have expertise in project management, people who have good understanding of the economic scenario and can predict the inflation levels in future. So this knowledge engineer will do what? It will collect the expertise of all these experts, and this expertise would then be actually fed into the knowledge base. Now this knowledge base is basically made by this knowledge engineer, and this contains the expertise of all such human experts, not just one, all such human experts. So the knowledge engineer would probably be talking to a number of human experts in that particular domain in which you are designing the expert system. Now in our case, in our example, we are designing the expert system for purpose of project appraisal, to find out which projects are going to be beneficial and which projects are not going to be of great benefit for the organization. So this is going to be the narrow domain that our expert system would address. Now this knowledge engineer has basically collected this information from all such human experts, and he has prepared this knowledge base, right? So this knowledge base has now been prepared, which contains all the information of the human experts. I hope you remember what we had said here: accumulation of all expert knowledge in a domain. Now where is this expert knowledge getting accumulated? It is getting accumulated here in the knowledge base. fine, and this job is being done by the knowledge engineer, hence the designation knowledge engineer, right? And then there would be an inference engine. Now what will this inference engine do? This will basically use this knowledge and it will apply some models and it will apply some analysis techniques, and this would give inference. It would give its result to the user through the interface, of course. So this would be the functioning of the inference engine, and this way basically this user will have access to the knowledge of a number of experts, and plus the analysis which results from the use of this knowledge. So he will have access to both of them and he will benefit from both of these things, right? And this is how the expert system works. And as I said here, what will happen basically, the user interface basically would pose questions to the user. For example, what is the likely inflationary scenario in the next 5 years? And the user would key in his response, and this response again would go to the inference engine, and based on this response also the inference engine is going to do the analysis, right? Now please have a look at this. This is arrow in just one direction, while there is arrow in two directions. What do we mean by this? Again, see, please understand, human expert is providing knowledge to the knowledge engineer, who is actually accumulating all that knowledge in the knowledge base, and then the knowledge base and the inference engine will interact, and they will actually be interacting with each other in a sense, in the manner that knowledge base provides some knowledge to the inference engine, and inference engine also is making further changes to the knowledge base. So this is a system which keeps on improving itself. How? The knowledge base provides inference to the knowledge base provides knowledge so that the inference engine can make inferences, can do the analysis, and then whatever the results of the analysis, they are also fed back into the knowledge base for future use. So it's a self-learning kind of a system, right? Likewise, the inference engine will provide information to the user, plus it will also pose queries, and the user would respond to those queries, and that is why this is shown by a double-headed arrow. The user would also be responding to these queries. Fine. So this is how the expert system works. And as I've said, the knowledge engineer does what? It interviews the expert and builds the knowledge base, right? Now let us talk about the components of the expert system. We have already discussed, we have already seen them. So just a brief discussion on these components. Knowledge base. Now we have seen how it is formed. It is formed by capturing the knowledge of domain experts. Domain experts which are expert in a particular domain, in a particular field. Now this specialized domain knowledge is stored as data and facts. Where? In the knowledge base. I hope you remember. And then this knowledge base will also contain some heuristics. What do we mean by heuristics? They are basically shortcuts of solving problems. You have been using heuristics in your daily life. For example, let's say you have come to the college and you want to look for your friend. You don't find your friend anywhere. So you have come to the college. You didn't find your friend in the class, and you are looking for him. And one way could be to go from every single room to the other room and then keep looking and keep calling out for your friend. But that would be very, very time consuming. And this method, however, would be very, very systematic, because if the friend is there in the college, you would certainly find it if you go to every single room, every single spot within the college campus. But it is going to take a lot of time, right? So what are you going to do? You are going to apply some shortcuts. So what do? You go to the field where generally you have found him sitting after bunking the classes, right? And if you don't find him here, you go to the chow mein shop, because these are the two places which he frequents. So you have adopted a shortcut to find him, right? So this is an example of a heuristic. These are shortcuts, mental shortcuts that we adopt to solve the problem in a more efficient manner, right? So the knowledge base will also contain heuristics, the shortcut methods of solving problems, right? And this knowledge would also be stored in the knowledge base. Fine. Then we have got the inference engine, a very important component, and this was not there in the DSS or any other subsystem of MIS. It applies the facts and rules in knowledge base. So whatever is obtained from the facts and rules, whatever is available as facts and rules in the knowledge base, the inference engine applies it, and it looks for new knowledge or new patterns. So basically the knowledge that is existing in the knowledge base is being utilized, and new knowledge or patterns are being discovered by the inference engine, right? And how would the inference engine be able to do this? By doing some analysis, it would be able to predict, it would be able to see new patterns in the data, right? So this is what the inference engine is going to do, and then we'll have the user interface. Now user interface, first thing, will generate report. Now that is something that you already know, so I'm not getting into detail of what report generation is. So it will be providing reports, it will be providing information in the form of visuals to the user. There could be pie charts, and there could be bar diagrams and various other ways of presenting this information. And the report could also be generated. However, more important aspect here is the inference explanation of the decision logic. What do we mean by this? The inference engine, which is doing what? It is basically applying facts and rules in the knowledge base, and it is trying to discover new information, new knowledge, which it will be sharing with the user, right? So the inference engine is also basically explaining why it sought a particular information from the user. I hope you remember that I told you that the expert systems actually work by posing queries to the user. In our example, the query that was posed was, what is likely to be the inflation level in the coming 5 years, in the 5 years, right? Now this particular query was posed, but why was this query posed? Now this was also provided as explanation by the inference engine. So once the inference engine completes the job, then what will they do? What will the inference engine do? It will also provide this information apart from the report. It will also provide this information to the user as to why a particular piece of information was sought. In our example, the inference engine was trying to find out, pose this query to the user as to what are the expected inflation levels in the coming 5 years. So why was this particular information posed? This would be explained by the inference engine. How was the solution arrived at? This would also be explained. So this is what we mean by the decision logic. So how did the inference engine arrive at a particular solution? This information would also be provided to the user, and this information is being provided because the user can assess whether the method, the approach used by the inference engine to arrive at the solution, that approach was solid enough. Then only the user would want to go by the result given by that particular expert system. If the expert system has used a very, very good procedure to arrive at the solution, right? So this would also be explained by the inference engine, and the inference engine would also explain why it has selected some options while it has rejected the other ones. So the inference engine would provide some alternatives for the user, to the user, so that he can make his decision, right? So the user is being provided with alternatives. This is number one. Just like in DSS, the DSS also never provided the one final result to the user. The DSS provided various alternatives that could be used. Likewise, the expert system also does not provide the solution to the user. It only provides the user with various kind of possible alternatives which are there. But why it is suggesting these alternatives and it is not suggesting the other possible alternatives? This is also going to be explained by the Inference Engine when it is presenting its conclusion and when it is presenting its findings to the user, right? In our case, for example, supposing the expert system tells us that you need to invest in project A and project P, right? So these are different types of projects. Supposing we had 20 different projects, so project A and project P are the projects in which the user can invest. Now this is what is being told by the expert system. Now why did the expert system select A and P as projects? Why it did not select B? Why it did not select, let's say, E? Now this would also be explained by the Inference Engine, and this would be explained through the user interface, right? So the explanation would be there, it would be done via the user interface, right? So basically what I'm trying to tell you, that the user interface would not only generate reports, but it would also let the user know as to how the decision was arrived at, what particular approach was used, what particular process was used, why particular information was actually sought from the user, why a particular question was posed to the user, and why particular possible alternatives to the problem were not selected while only a few were selected. Like in this case, the expert system gave us this result that we should go for either A or P, but it did not give us, it basically told us that you should not go for B or E, these two projects. So why is it suggesting this? Why is it suggesting that you should go for A and P and not for B or E? That would also be explained by the expert system through the user interface, right? So this is how user interface in expert systems is very, very different from that in the decision support system. Now let's talk a little bit about the characteristics of the expert system. I hope you understand that again it is futuristic. It is not talking about what has happened in the past. It is not summarizing the past records for you. It is basically telling you, helping you in making a decision for the future. So it is basically oriented towards future, right? Can handle highly unstructured situations, and that is why it is being used. I told you expert systems are generally made use of by the top management, right? And the expert systems can handle highly unstructured situations, novel situations which have never happened earlier. Because if they are those kind of situations which happen on a regular basis, then you can always have other standard operating procedures to deal with these kind of situations. However, this problem was very, very unique, very, very new, and that is why the expert systems would be able to work, and they are actually relevant for these kind of unstructured situations. And how do they solve them? They make use of all the knowledge that they have accumulated from the expert, and they apply the various analysis technique to provide the solutions to such unstructured situations. They deliver reliable solution. However, we should in fact qualify this remark by saying that the reliability would still be less than an information reporting system or the TPS. Why? Because they are not oriented towards the past. They are not giving us a summary of what has happened in the past. They are actually trying to give us what might happen in the future. So though the solutions could be reasonably considerably reliable, still the reliability would be less than the information reporting system, which was basically oriented towards past, and it was giving us just a summary of what has happened in the past, right? So the reliability is still going to be less than the IRS, though it is still significantly high, but still less than IRS. These expert systems also explain and provide justification for decision. I have given you this idea that they also provide us why they arrived at a particular alternative. Why have they suggested a particular alternative and why they have rejected a particular alternative. The process adopted by them. The reason for posing queries to the user. Everything explained. So in that sense, the expert system don't only provide us the solution, they also provide us the decision logic, the reason behind those solutions which they have suggested. Now this is one very unique feature of an expert system, because now as a user I don't only have the alternatives to choose from, but I also know what is the reasoning behind every single alternative. Based on the strength of that reasoning, I can choose the different alternatives. So this is one very unique thing about the expert systems. And expert systems are suitable for use when are you going to use the expert systems? Naturally, when the human expertise are scarce, you do not have sufficient number of human experts. So then you basically delegate this task of finding out solutions to such unstructured situations to the expert system, because the human experts are not to be found easily. They are rare, or they are very costly. Naturally, if they are rare, naturally they would be charging more. So you don't want to spend that much money on a regular basis. So you do what? You install an expert system. And the problem involves complex logic or large number of rules, which is just not possible for a human expert to do manually, right? So such problems which involve very complicated logics and large number of rules have to be taken care of. There the expert systems would be of use, right? And I'll give you examples. For example, looking at the chest scan, the lung scan of an individual, and predicting whether he is likely to suffer from lung cancer in future. This could be one example. So here what you do, you may make use of the expert systems, right? Naturally the human experts, the doctors, the specialists are very rare, at least not there in, for example, in pathology. So then you can rely on such expert systems, fine. Again, as I said, the various uses: investment management, which particular project to invest in, or for example which particular stock to invest in, you can go for an expert system. Which particular medicine to prescribe to a particular patient depending on his symptoms. So all the symptoms of the patient would be fed to the expert system. And how is this particular expert system going to work? It will have its knowledge base, which will be formed from the knowledge collected from various doctors who have expertise in these kind of diseases. And then there would be an inference engine, and then the system would pose queries to the user. Okay, for example, since how many days is the patient suffering from cold? So you will mention as user you will have to respond to this query. Then it will ask whether some other medications are also going on, whether the patient is also on some other medications, is he taking some other drugs also. You have to then provide your response. So these kind of questions the expert system will ask, just like an expert would do before diagnosing the problem, just like a doctor does before diagnosing a problem, right? And this kind of questions the expert system will ask, and based on the responses provided by the user, it will diagnose the disease, and then it will prescribe the medicines. Again, criminal investigations also. Criminal investigations, finding out who committed the crime. So what will happen? For example, there is a crime scene and then you have to find out who actually committed the crime and who could be responsible for the crime. So for example, the question that would be posed by the expert system would be, for example, where were the blood stains found? How far from the body of the deceased? Let's say in a crime scene somebody was killed. So how far from the deceased, from the body of the deceased, were the blood stains found? And you will have to, as user, you will have to provide your response. Okay, 3 meters from the body, 5 meters from the body, or something of this sort. And the criminal investigation expert system will let you know as to what was the weapon which was used to kill the victim, right? So this kind of job is performed by the expert systems, right? Now then, naturally there are limitations. What are the limitations? First thing, naturally you can understand it's going to be very, very costly. It requires a lot of fine tuning. You will have to develop and then you will have to further fine tune. It means you will have to further improve it in bits and pieces. So that is going to be very, very costly affair. You will have to develop it, fine tune it, and not only this, you will have to maintain it. Maintain it would mean that, I hope you remember. Let me get back to the diagram. Do you remember this aspect? The inference engine is feeding the information back to the knowledge base also. You know that the knowledge base is providing the knowledge to the inference engine, but then the inference engine is doing the analysis, and the new pattern that it has found out, it will feed back into the knowledge base also. So the knowledge base would keep on getting modified with every use of the expert system. You understand this point? And that is what I mean by saying maintaining. You have to maintain, in the sense that the knowledge base would keep on getting upgraded. So that also has to be provided for. So this again is going to be very, very costly. Scope limited to, as I said, very narrow domains. We have talked about how investment management can be of no use to you if you are trying to find out which particular product to launch in the market. It is going to be of no use to you. Likewise, the expert system which is prescribing medicine cannot be of use to you if you want to know what all physiotherapy activities or what all exercises should the patient be suggested, because it is meant only to suggest and prescribe medicines. It cannot prescribe exercises, right? In some ailments, the doctor also prescribes you some exercise. For example, supposing there's some kind of a pain in the back, then naturally the doctor will suggest you some exercise. But this particular system, if it is meant only to prescribe medicines, it would not be able to suggest exercises. So basically the scope is limited to very, very narrow domains, right? Again, the designing of the knowledge base is very, very difficult also, because you have to extract the expertise from human experts and then include it in the knowledge base. So first you have to extract the expertise. In itself, it's going to be a challenging task. Not many people are articulate enough. So not many experts would be articulate enough, and they may not be able to talk about everything that they know. Not because they're not willing to, but because they're simply not articulate enough. So how do you extract the information? How do you extract their expertise? And then this is knowledge. Knowledge is generally in a tacit form, which is very, very difficult to communicate and very, very difficult to document. I'll tell you an example of what we mean by a tacit knowledge. For example, if somebody asks you how to prepare tasty Maggie. How to prepare Maggie is a different thing. You can easily ask somebody how to prepare Maggie, and you can do that. How to cook Maggie. But how to cook crispy and very, very tasty Maggie. Now this would require, naturally, some expert cook will have to tell you this. But even then, he would not be able to tell you about every single thing that he has to do, because maybe when the color changes from yellow to brown, then he stops cooking it and then he serves it. But then, don't you think it is going to be difficult for him to communicate this aspect to you, that okay boss, when the color changes from yellow to brown, or maybe even what shade of brown and what shade of yellow is going to be difficult for him to communicate to you. So describing this kind of a tacit knowledge at times is very, very difficult. It's just not possible. How to tie up the shoelaces, for example, don't you think it's going to be difficult? Can you explain it to somebody? You will have to show it to him. You simply cannot explain it to somebody. How to tie your shoelaces, how to prepare the tie knot, you simply cannot explain. You'll have to show. So such knowledge is very, very difficult to document also, and this is one major limitation of the expert system. And then you may try to collate all the information, but still some or the other pieces would still be remaining. So the knowledge base is never going to be complete. Whatever one human expert knows, he would not know every single thing. He might know a lot, but he would not know everything, and this is going to be a problem with expert systems. And since the expert system cannot have all the possible information, it cannot have all the possible knowledge, it would always be incomplete, and it would not be able to account for all the possible real world scenarios. All whatever is possible, it would not be simply able to account for it. And that is why, though it would provide you solutions, but the solutions, again, they may be of high reliability, but they are still not 100% foolproof, right? So the solutions suggested by the expert systems may also not work out, though their probability of being effective is very, very high. We have said that they are very, very reliable. We have said it here, but still you can't say that they are going to be 100% reliable, right? So this is it from my side as far as expert systems are concerned. Now we are through with our discussion on expert systems, and the next thing that we'll take up is the executive information system. So thank you very much for your time.